Then we get into what are known as frequency tables, histograms, and polygons. So frequency tables, frequency histograms, and frequency polygons. So, and we also have to talk about frequency distribution. So distribution is basically a set of intervals, usually of equal width, in which data is organized. So if we want to make a frequency distribution table, we first have to determine the range of the data and determine a suitable set of intervals. Somewhere between 2 and 12 is usually acceptable. Then we make a chart with our intervals using a tally, which will give us what our frequency is. Divide the range by the number of intervals, find the interval values into the chart, tell you how many times each data is in each interval. The numbers for a interval is going to be up to and including the last number, which actually deals straight going into a histogram. And then we're going to find total frequencies. So no better way than to look at an example to help understand what these different parts are. So the following is data that represents the flow rates of the Red River from 1950 to 1999. 9 of these were floods. So we're going to make a frequency table. First things first, in order to make a frequency table, we have to determine our range. So we have to determine what is our highest value and what's our lowest value. So we have a 3,000 here. I have 4,587. Now, each of these would be in meters cubed per second. Our lowest value, I'm looking at everything. See, we have a 357 there, 187 right there. I'm pretty sure 187 is our lowest number. And that would be incorrect. I can see that there's a 159 in there. So let's change that. So 4587, subtracting the 159, 4428. So then we're going to determine a suitable set of intervals, somewhere between 2 and 12. Now, if you have, the rule of thumb is, if you have everything too few, everything gets bunched. And if it's too much, it's too spread out. For this case, because there's so many data values, it would probably make really good sense to have 10 intervals, which is between 2 and 12. Now you could set up your own, you could say 8 and anything like that. We're going to make a chart for following tiles. And we're going to help fill in our intervals by doing this. If we take our 4428 and divide by 10, we'll find out how large our intervals are going to be about. Now that division will be 442.8. So let's round it up to a nice number that works out to be about 450. So by creating our chart, we're going to fill in interval values. So this part 3, I had already made the chart, and we divided our range by the number of intervals that we wanted. We're going to fill in our interval and make tallies of how many times each of these intervals actually occur. Now, one thing I do need to say about these intervals, sometimes, especially if we use a rounded value here, it sometimes goes higher or lower than the 10 intervals. For example, we may have only 9 intervals or 11 intervals. But having an approximate 10 intervals is going to be good. As long as we're somewhere between 2 and 12, we'll be fine. If we have less data, we probably want to have less intervals. More interval or more data, we would probably want to have more intervals. So because we're having flow rates of approximately 450, we're going to first set up for between 0 and 450. The next rate would be between 450 and 900. And we're going to fill in each of these intervals like so. Now, just a side note, I do love my 45s. Because it works out really nicely with weights. But I'll fill in the rest of the chart. So just as I'm finishing up with my chart, I have to go through a little bit of rational thinking in here. So the last interval that I've stated in here is a range from 3,600 to 4,050. My largest number is 4,587. I'm not going to make one of my ranges bigger than the other. Which means that that 4,587 would just have to be put into another range. It have to be put into a larger set. And there we have it. Oh. This would allow us to have all of our data displayed in a frequency table. Now you'll also notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 intervals. If we had rounded this number up to 500, we would only have 10 intervals. But we had made an estimate of how many intervals we wanted. We got to 11. That's fine. The next step that we're going to be doing is we're going to make a tally of where are each of these numbers in our table. For example, 3,058. 3,058 would be in this range. 1,065 and 1,008. 1,065 and 1,008 would both be in this range. Our next value is 357. Well, that'll be down here. But 524 would be in this range. I'm going to help finish the rest of this table. And as I finish off my tally is going to look like this. I have 5 in between 0 and 450, 9 in this range, 8 here, 12, 8, 3, 4, and 1 way at the top there. This is what it means when we find the total frequencies. Now we're going to be using this chart. We're going to use this table because that's going to help us make a histogram. So a histogram is the graph of a frequency distribution in which equal intervals of values are marked on a horizontal axis. The frequencies associated with these intervals are indicated by the areas of rectangles drawn for these intervals. Now, one thing I do need to make a note of, we do talk about things that if you have a number up to including, for example, if we had something that was exactly, say this number was exactly 1,800, this number would only fit in this range. It would not fit in this top range. In other words, this specific range is in between 1,350. Sorry, that's incorrect. So it would not include 1350, but it does include 1800. Just like this range does not include 1800, but it does include 2250. So what we're going to do is we're going to make a histogram of this data. So we're going to make a frequency table, label the x-axis with the frequency intervals, label the y-axis with the frequencies, and then we're going to draw a rectangle for the values of each of these intervals. So the first thing that we can do is we already know what our rates are. We're between 0 and 450, 450 to 900, and I'll fill this in. So I filled in what the flow rates are. I'm just going to write down what our frequencies were. We had 5, 9, 8, 12. So I do all of this. Add in my lines just to help split them apart. A 5, 9, 8, then a 12. 8, 3, 4. And we had nothing until this bottom range there. So what we're going to do is we're going to use this to create a histogram. Now there's a few careful characteristics that you need to know about histogram. One of the big thing is a histogram should not have any gaps between the rectangles, and you should always use a straight edge. Now with technology, I can do that relatively well, but I'm still going to have to make sure I do things properly. So I'm going to set my flow rate down on the x-axis, and I'm going to put my frequency on the x-axis. So let's see, I can do the frequency probably the fastest. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares, which means I can make every single square worth 2. So to fill in our rates, I have 11 intervals. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 squares. So on your notes, I'll add an extra little bit here. So I'm gonna make some more here. Heck, I'll make all of this nice and thick here. So I just made this a little more visible. Now I'm going to fill in my actual flow rates. So I'll make every 2 squares worth that 450. 1350, 1800, 2250, 2700, 3150, 3600, 4050, 4500, and 4950. So the rest of my work here is going to be to fill in my chart. So I'm going to be using some straight lines, my straight edges, because from 0 to 450, I'm going to have to fill in a rectangle of 5. And there we go. From 450 to 900, I'm going to have to fill in a rectangle of 9. Similarly, 900 to 1350 will be 8. I apologize for my line not being absolutely perfect. I'll change that over to make it better. There we go. That looks a lot better. Same time, this line could probably be moved over. Yeah, that looks better. Okay, so from 1350 to 1800, though, there was 12 in that flow rate range. 8 in the next. 3 in that next one. 4 in that next range. And then there wasn't anything until this very last range. Oh, lost my line. Which comes out and looks like that. Now you'll notice in all of this, I made sure that all of my lines are as good as possible. At the same time, making sure that every single one of these values, I'm still not getting that last line there. Got to just go off on the side there. Yeah, I'll drag it. So what I'd kind of like you to do is fill in some color. Doesn't have to be perfect, but it does have to represent your data. Now, this is a histogram. We can see that over the course that there was lots of different flow rates. Kind of had a nice peak at frequency in between the 1350 and 1800 and drop down. Obviously, we have something up here. I do make a mention of what a frequency polygon is. So I'm just going to make this as, because just at the very beginning, a frequency polygon is something that you just connect the midpoint of your histograms. So in each of these ones, these parts down here will be zeros. And you'd use a straight edge and connect them. So that part of this is the frequency polygon. It looks very much like a line graph, and it essentially is. So I'm just going to leave that up there, just so you know what it is. All right. Now, the last question in this is asking at what point does flooding occur? Well, that's kind of ambiguous. At the same time, it's said right in the question that 9 of these flow rates, or 9 of these flows, yeah, were floods. Well, that's going to be easy to identify some of it. For example, there's one here. There's 4 in this range and 3 in that range. So that means that that's 8. So that means that one more in this range would have to be considered as a flood. So let's look and see what numbers are in the 1800 to 2250 range. So 1800 to 2250. See, that's one. That's one. Let's see, how many was it? 8. Yeah. 1800 to 2250. That one's it. That one's over. That one's in there. 1, 2, 3, 4, 5, 6. There. So if we look at it, see, that's 1900, that's 2209, that's 2180. So 2180 and 2209. Yeah. So that means that flooding, so those are the top two in this range. There'd be 6 more, and then there's these two things. So somewhere in this flow rate, in between 2180 and 2209, it would be classified as a flood. A nice logical number would probably be 2,200 meters cubed per second. So that's using a little bit of deductive reasoning, or inductive specifically. It's looking at a pattern. Alrighty, you can have some fun.